This video is going to go over chemical formulae, formula units, and molecules, and how those things are related to each other. So let's start by thinking about a lab sample. We're going to start with a macroscopic sample, one you can see and touch. On the left is a sort of magnified image of a sodium chloride crystal that you can see with your eyes. And on the right is a beaker of water. Now, if we zoom in, put on our molecule glasses, we can zoom in, and if we could do that, we would see individual atoms and ions. And so on the left, if we zoom in on the sodium chloride crystal, we would see sodium and chloride ions connected together through ionic bonds, and they would be connected to form this sort of cubic shaped lattice, is what we would call it. And if we zoomed in on the beaker of water on the right with our molecule glasses, we would see individual molecules of water where we have oxygen atoms connected covalently to two hydrogen atoms. Now, if we then further zoomed in and we look at just a single formula unit for sodium chloride, for ionic compounds like sodium chloride, we refer to a formula unit. It's sort of the smallest combination, sort of the lowest common denominator, the smallest unit you can get of a given ionic compound. And so it represents the ratio of cations and anions that are present. And the reason we use formula units and not sort of a molecular formula is because as we discussed in some previous videos and earlier in the semester, sodium chloride samples are going to vary in the number of ions that you have. Large crystals are going to have more ions, small crystals are going to have fewer ions. All you really know is the ratio. The ratio will always be 1 sodium to 1 chloride because that is the ratio that would give you a neutral, zero overall charge. And so some formula units might have 1 cation and 2 anions, for example, calcium chloride. Some might have 1 cation and 3 anions, and so for example aluminum nitrate. But the formula unit is going to be sort of the ratio of cations to anions. As opposed to water, where you have individual molecules, that's kind of like a formula unit, except you can have a single molecule, and then a different sized sample of water would contain different numbers of molecules. Now, if we relate molecules and moles to each other, the chemical symbol shown on the left has a couple of different meanings if you think about it. One molecule of water definitely contains 2 hydrogen atoms and 1 oxygen atom. But another way to think about it is that 1 mole of water contains 2 moles of hydrogen atoms and 1 mole of oxygen atoms. And so just like a chemical reaction equation has stoichiometric coefficients that might mean molecules and might mean moles, the chemical formula can be interpreted 2 different ways as well. You could talk about it with respect to atoms and molecules, or ions and formula units, or you can talk about it with respect to moles. And both of them are useful interpretations depending on the purpose. So if we look at sodium chloride instead, we have 1 formula unit of sodium chloride that you see here. 1 formula unit of sodium chloride contains 1 sodium cation and 1 chloride anion. How 1 mole of sodium chloride is going to contain a mole of sodium cations and a mole of chloride anions. And so you can see that the numbers have 2 meanings. And that's because moles and molecules, or moles and ions, or moles and formula units, those are all directly proportional to each other through Avogadro's number.